Hello, guys. In today's grade 12 physical sciences vertical projectile motions exam clinic, we are looking at the Eastern Cape's physical sciences paper 1 of September 2025. As you can see, this question here, it is 17 marks. So we must spend 17 minutes in total, unless if there will be things that are outside our control, like mistakes that are made in the questions. Okay, but otherwise, let's proceed. Let's see, this is question 3. Okay, so this is question 3, and let's start. A ball A is thrown vertically upwards with an initial speed, so let me just get this data, with an initial speed of 2.5 meters per second, right? So remember, it's thrown vertically downwards, okay, from a point X above the ground. So delta Y is X, okay, above ground, all right? Then at the same instant, right, let's talk about this guy here. The time here is at the same time, okay? At the same time, a second identical ball is dropped. Ooh, so this one, its initial velocity dropped. So it's 0 meters per second because it's dropped from a point Y. All right. So this one here, its height is Y meters above ground. All right. Above the ground. Okay, above the ground. Now, let's see, what do we do then? They also say this Y is 5.2 meters below X. So it is 5.2 below I man. It is 5.2 meters below X. All right, cool. Now let's see. Both balls hit the ground at the same time. Both balls hit the ground at the same time. So both hit the ground at the same time. This is very important. Okay, both hit the ground at the same time. So that means they have the same delta t. All right. 3.1, define the term freeform. This is motion of an object. Okay, motion of an object where the only force acting is the gravitational force. Okay. Where the only force acting is the gravitational force. Okay, I need to sort out this cursor thingy. The way it's blinking, I'm not happy. Right, 3.2, calculate there, 3.2.1. Time taken by the balls to hit the ground. All right, time taken by the balls to hit the ground. So this is very important. So I will choose one. Maybe let me choose downwards being positive, okay? So let me say downwards is positive. Guys, even if you choose upwards being positive, it's still okay. So what do we have? I'm gonna go with, let me see, for object B. Let me start with object B because it has initial velocity of 0. I will use the formula. I know its height and I also know its initial velocity. So that makes things easier for me. All right. So I will choose delta Y equals VI delta T plus half A delta T squared. This delta Y is the downward motion. So the distance, let's just call it Y. So we'll just call it y just like that. Okay, and then the initial velocity is 0. The time we do not know. Acceleration will be positive because we said line downwards is positive, right? Cool. So we have y equals 4.9 delta t squared. If you like, call this equation 1. Then let's look at motion of object A. Okay, let's look at motion of object A. Object A, once again, I will use the same equation. Delta y equals vi delta t plus half a delta t squared. What is delta y? Delta y will be careful here. This is not just x. So maybe I should just use x for now. I will just say x equals, what is the initial velocity? It's 2.5 meters downwards. So it's going to be positive 2.5 delta t, isn't it? Plus half acceleration. It's positive 9.8 because it's the downward motion. Delta t is unknown. Now, something that you need to know about this x. This x is the same as saying y, okay, is the same as saying y plus 5.2. Do you guys agree? It's the same as saying y plus 5.2, right? Uh-huh. All right, let's go. This becomes, or rather, it equals 2.5 delta t plus 4.9 delta t squared. There's something we said about y. We said y is the same as saying 4.9 delta t squared. So this becomes 4.9 delta t squared plus 5.2 equals 2.5 delta t plus 4.9 delta t squared. Agree with me that the 4.9 delta t's will be cancelling. So we will have 5.2 equals 2.5 delta t, right? Let's see now. 5.2 divided by 2.5, we can see that therefore delta t is 2.08 seconds, right? Delta t is 2.08 seconds. How is that? Perfect, right? So this is the time taken by both balls to hit the ground. Proceeding. Whew, seems like we've been doing this for a very long time. 3.2.2, we need to calculate the velocity with which ball A strikes the ground. Okay, we know initial velocity is 2.5 meters per second. The time is 2.08 seconds. We are only looking for the final velocity. Once again, I will choose downwards as positive, right? Guys, remember, even if you choose upwards being positive, it's still okay. Okay? So let's see. We have final velocity equals initial velocity plus acceleration times delta t. Initial velocity was 2.5. Acceleration is positive 9.8 this time, and the time was 2.08. Right? Let's go. This gives us, correct to 2 decimal places, 22.88 meters per second where? Downwards. All right? Perfect. Now, let's see. We are done. This was 3.2.2. 3.2.3. There's a mistake here. It's not a big deal. So 3.2.3. Let's see. Calculate the height of point Y above the ground. All right. 1. What do we know? The height is unknown. initial velocity of ball B, because when we talk of y, we're talking ball B. Initial velocity of ball B is 0. The duration of its motion was 2,08 seconds. Once again, I will choose downwards being positive. So downwards is positive. What do we have? Delta y equals VI delta t. Okay, equals VI delta t. Then what else? Plus half A delta t squared. Right? Now, initial velocity is 0. The time is 2,08. And then half, once again, acceleration this time will be positive 9.8. Once again, the time is 2,08. But this time, we square it. All right? Let's see. 4,9 times 2,08 squared. We get our y, so this is y, by the way, capital Y, is 21,20 meters. Okay, this is 21,20 meters. Therefore, the height is 21,20 meters. All right, perfect. 3.3. So 3.3. On the same set of axes, sketch the relevant velocity time graph for the entire motion of both balls A and B. Okay, velocity versus time. We chose, maybe before I proceed, let me just say I'm still gonna choose downwards being positive. When downwards is positive, the slope will be positive as well, right? So we will choose this one here. Then let me choose, I'm not choosing, time is indeed measured in seconds, and velocity is measured in meters per second. Now, object B started at rest, meaning the origin, right? So this is the 2,08. Then object B started at some speed, or with some speed, which was 2,5, and this is 0. Okay, so this is our velocity versus time. Let's see. They said indicate on your graph the corresponding velocity and time values. Okay, label your graphs. I think we did. Did we have to find the velocity with which both objects strike the ground? I know we calculated velocity that object A struck the ground with, which was 22,88, isn't it? It was 22,88, right? And then what was the velocity that the thingy struck the ground with? So let's see, 0 plus 2,08 times 9.8. This is for object B. Let me just do this. So allow me to change this guy slightly, and then I'm gonna be doing this. I'm gonna draw them. Yeah, okay, just gonna change it slightly, guys. So these two will be and this is 2,5, and then that one I found it to be 20,38. Okay, I found it to be 20,38. Not that we calculated it before. So this is object B and this is object A. So this 20,38, how did we get it? This is for object B, right? Final velocity equals initial velocity plus A delta D. This was 0 plus 9.8 multiplied by 2,08. It gives you 20,38. 20,38. Okay? The question didn't really ask you to find this velocity, but we just gave it. And this is how we answer these questions. All right. With that being said, it's a wrap and bye bye.